So, welcome back. Today we're going to finish up all of our 5 notes. So, we're just going to continue to practice with proofs and combine it all together. We're going to practice CPCTC today, which is exciting. Let's go ahead and jump right in. We are given that BC is perpendicular to CD. So, we're given that BC and CD are perpendicular. So knowing that perpendicular means that it creates 90-degree angles. That's it, right? And then we're also given that AB is perpendicular to AD, again, creating 90-degree angles. So we've maybe hopefully got some ideas going on in our brain of like, okay, so at least I can prove that A and C are 90-degree angles. And then you're given that angles 1 and 2 are equal. Realize angle 1 and angle 2 are outside of your triangle, not inside your triangle. So we have to find ways to get it inside of our triangle. I've got a couple ideas going around in my brain. I'm not sure which door to take in my labyrinth of this proof. I'm going to write down what I do know and then choose a path to take. And then angle 1 equals angle 2. Squeeze. Given. All right, I know that I've got perpendicular lines, which I know that that those breadcrumbs, that garden path, that rabbit hole, whatever you want to call it, is going to lead to 90-degree angles. And then I know that angles 1 and 2 are equal, so I need to talk about angles that will then lead me to the inside of the triangles that I want to talk about. I'm going to first go with the 90-degree angles just because I want to just kind of get it out of the way. So I'm going to talk about those guys being equal to each other. Not equal to each other, just 90 degrees. Angle C equals 90 degrees. Here I can just call it by one letter because there is only one angle at that spot. Again, remember if there's multiple angles happening at that spot, then you have to use the 3 letters or you have to label it in some way. But sometimes the labels can get confusing if you don't label it well. As maybe you've seen on some of the proof practices we've done. I'm going into my diagram to just say, hey, I've said that they're 90 degrees and that's it. I don't know if I want to prove that this is a right triangle or if these angles are equal, right? Proving that they're both 90 degrees has 2 different doors that go out of that room and we need to know which one to take. I'm going to then reshift my focus onto the angles 1 and 2 to be like, okay, well, if I'm going to talk about those angles, what path is that going to lead me down on? So how do I make sure that my paths kind of all join to the same spot at the end? And I know that if I have a line that connects all the way through, and then 2 angles that make up that line, that those 2 angles would then be linear angles. And I do know something about linear angles. I know that they're 180 degrees. So then you're going to start noticing that there's going to be patterns of how we prove things. I'm going to call this angle 3 and angle 4. I'm going to prove linear angles and set them all up into 2 separate equations adding up to 180 degrees. And then I'm going to use that to then prove that 3 and 4 are equal. And once I prove that 3 and 4 are equal, then maybe I'll have a better idea of how I'm going to use that 90-degree angle up top. But before I get way too ahead of myself and lose track of my thought process, I'm just going to set up that relationship. I need to prove that angles 3 and 4 are equal. In order to do that, I need to say, hey, they're linear angles, and do some manipulation and magic here. angle 1 plus angle 3 equals 180. Angle 2 plus angle 4 equals 180. Linear angles add up to 180 degrees. Okay, now going back and looking at this algebraically, I want to prove that angles 3 and 4 are equal, which means I need them to be in the same equation. So how do I connect them? Well, since they're both equal to 180, and I know that 180 equals 180, then I can say 1 plus 3 is equal to 2 plus 4. And since I'm taking out 1/2 of an equation and replacing it, that's going to be my transitive property of equality. Again, shifting back to here, I want to prove that 3 and 4 are equal, and I've gotten one step closer by having them in the same equation, but now I need to get rid of all the other things that are going on in that equation in order to get just 3 and 4 by itself. In order to do that, I need to get rid of 1 and 2. Thankfully, we know that angles 1 and 2 are equal, so again, starting to notice this pattern, right? We're going to take out one of them, only one of them, and replace them with the other. If you replace both of them, then you're going to find yourself in this roundabout spiral of doing the same thing over and over again. Because if I had 2 plus 3 equals 1 plus 4, I would be in the same spot I was before. A little bit of poetry for you. And now, since I replaced only one of them, I can then, in my next step, subtract out angle 2 from both sides and only be left with 3 and 4. That guy, since I only took out one small piece, is substitution. Next, I get to say that angle 3 equals angle 4. If you wanted to show the math of like, hey, minus angle 2, minus angle 2, you could. It's not needed because the reason why you don't need to show the math is because you're explaining the math. That is because I used subtraction. Okay, now I've said those guys are equal. And now I need to take a step back. What do I want to prove here? Do I want to prove HL? Probably not, because I maybe could prove one thing about sides. I will be proving one thing about sides, but I have no other sides that I can prove. And why would it give me something else about an angle if I was going to use HL, right? Because HL only requires one angle, and that's to make it a 90 degree. So if they're going to talk about another angle and you're given, they're probably guiding you towards using a different reason besides that. So we're going to definitely aim for two angles, and that is either angle side angle or angle side, either one of those. Now, if it was angle side angle, I would have to have the side in between those two angles, which is this guy right here. And I don't know anything about that side length. I don't know anything about it at all. However, BD, I do know is equal to BD. So then I could prove that those guys are equal to each other. So that would be good. That would give us angle side. I didn't mean to erase it, but it works. Okay, so I want to say that angles A and C are equal to each other. I have to say that angles A and C are equal to each other. If you had said that earlier in your proof, awesome, as long as it is a separate step. Okay, sometimes this happens, especially when it's the first year I've taught a new class, where I run out of places to write, and you might also be running out of places to write if you're copying me. So what I do is I go to the side and I create a second t-table. And then again, a big reason why I number my steps is then for me to be like, oh, okay, I left off at 6 here. And then over on my second t-table, I'll start with 7. It doesn't look the best, but it is what it is. So I need to prove that angles A and C are equal to each other, because in order to do angle, side, you have to say that that angle is equal to that angle specifically. You can't imply it. You can't say, well, obviously they're both equal to 90 degrees. No, obviously. You have to say that they're equal. Seven, angle C equals angle A, and that is my transitive property of equality. Okay, if you are still doing this, this is an angle. This is an angle, and now we just need our side, and that's BD. Reflexive property. I'm going to go mark it in my diagram. And now I have that BAD and BCD are equal to each other. Triangle BCD is congruent to triangle BAD because of angle, side. Drop the mic. That might be one of the longest proofs. I think it is the longest proof we've done in this class so far. It will continue to get longer. Just remember that we're going to start going down these like separate little paths, right? In order to prove that angle 3 and 4 were equal to each other, we now have this whole other like mini proof within the proof to prove that those guys are equal to each other. So there's going to be a lot of like kind of side quests, almost like a video game. It's not the main quest, but it's a side quest. Not exactly like a side quest because it is required in order for you to like meet your final boss, which is that these two triangles are equal.